Hi everyone, and welcome to section 3.5, and here we're going to start talking about complex zeros. So thinking of the quadratic formula, when you get that negative under the square root, we'd have that I showing up. So we're going to start including those as possible zeros as well. It is very possible that there are polynomials that have all complex zeros. And in those cases, sometimes it's just impossible to forget them. We are going to learn or look at some examples that actually work. So in here, the examples we have will work for us. There are lots of examples out there that don't work nicely, and then there's different systems or different ways to try to get ideas of what those zeros are. But a lot of times algebra does fail us, and we have to look at other methods. But we do want to look at the ones we can do. So that's where we're going to start in 3.5. And we're going to include the complex zeros and the fundamental theorem of algebra. We did see the fundamental theorem of algebra when we did 3.4. So I'm going to bring back that one page of notes from 3.4 that we did. And we had that every polynomial has at least one complex zero. And that is actually the fundamental theorem of algebra. We also then extended it, saying that if we can find all the zeros, we can factor it. And then we also said that if we had a polynomial of degree n, it has n zeros. So looking at the multiplicity. So we had those three things from the previous section. We are going to add one more piece to it in this section, and then we're going to do some examples. I will warn you that these examples do take time, and so this assignment may take some time, but you just have to be patient with yourself. So the one thing we are going to add is if we have a polynomial. So if the polynomial, and we like to use the letter P for polynomials, if it has real coefficients. Okay, so not complex coefficients, we have to have real coefficients. Does not have to be integer coefficients like that P over Q thing was, but it does have to have real coefficients. Excuse me. And we have, and if the complex number, and we like to use Z for complex numbers, so Z is a zero of P, then its complex conjugate, and the notation our textbook uses for conjugate is that Z with a bar across the top, is also a zero. In other words, they appear in conjugate pairs. To remind us what the word conjugate, and that's a U, not an A, conjugate is, for example, if you had 1 plus 3i, the conjugate to 1 plus 3i is 1 minus 3i. So we'll get those conjugate pairs. And if you think about the quadratic formula, we had that negative b plus or minus square root piece. This is where the I would come from. Hence the reason we get the positive and the negative portion. So this is kind of where it's coming from, and if you look at the simplified version. All right, so let's start with just finding some zeros. And we'll start with something, I don't know. Let's look at x cubed minus 3x squared plus x minus 3, and we want to find, all the zeros. Okay, so first things we have to remember everything we did in 3.4. This is a third degree polynomial, so it will have at most 3 zeros. So every polynomial of n degree has n zeros. Some of them may be duplicated. We could do the p over q thing. So remembering that the p is factors of the 3, the -3, so we'd have -3 and that plus or minus 1, and q is going to be 1. So our answers would be plus or minus 3 or plus or minus 1 would be our choices. But I also want to, sometimes we don't want to just dump right into all these little things. We want to always try to take a step back and look at the bigger picture. This is a third degree polynomial, but it also has 4 terms. So I'm hoping some little dings and things are going off in your head, some little light bulbs are coming on. 4 terms, in my mind, ding, 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 I hear factor by grouping. So I'm going to look and try that first, and I'm going to try because I see the 1 and the 3, the 1 and the 3 kind of floating in there. So I'm going to take out an x squared out of this first piece, leaving me with x minus 3, and out of the second one I can take out a 1, leaving me with the x minus 3. So pulling out that x minus 3, I then have the x squared plus 1. So my zeros I can get from looking at this part. So this one I notice that x will be 3, will give me my 0. This one I have to do a little bit of work because I have the squared in there. I'm going to move the 1 to the other side because I don't have an x term in there, otherwise I would try to factor it. And now what I will do is take the square root of both sides. But when I take the square root, I have to remember the plus or minus, and I'm going to be taking the square root of -1. Now if we were looking for just real zeros, this would not give me any real zeros. But in the complex world, which is a little bit bigger than the real world, we know what the square root of -1 is. And we have defined the square root of -1 to be simply I. So here are my 2 complex zeros and my 1 real zero. So there's my 3 zeros. All right, let's get some more paper here so we can practice another example. And let's try something like this guy, because I think I can do this one on this video still. 3x to the 5th minus 24x cubed and plus 48x. And we want to find all of our zeros. Again, find all of the zeros. And they're not going to ask you to find all of the zeros on something that you can't find all of the zeros for. So it's going to be something that we can handle. I see a 5th degree polynomial, so that means we will have 5 zeros. I also am going to take a step back, looking for something simple first, and I notice that there's an x in all of my pieces. And actually I see a 3, so I'm going to pull that 3 out. So let me start that over. So 3x, and then I'll have an x to the 4th minus 8x squared plus 16. Hopefully I did that right. I'd hate it for me to make mistakes in these videos. That's the downfall of teaching online versus teaching in class. Usually in the classroom someone would say, Miss Chapel, you have an error there, or isn't that supposed to be a? But anyway, so we already know from here that x equaling 0 is a 0. And if I put that 0 back in there, yes, I did get a 0. The other 4 are going to come from this x to the 4th minus 8x squared plus 16. Now I'm also going to take a step back because this is something that you want to kind of keep in your toolbox. And when you see 3 terms where the exponents go down by half, and then you have a constant term, think to yourself hidden quadratic. So I'm going to let u equal x squared so that we can see it more directly. And this will then turn into u squared minus 8u plus 16. And I can factor this. So I'm looking for 2 numbers that multiply together to give me positive 16, that add together to give me a minus 8. I think that works. Okay, so u is going to be then equal to 4, but u is x squared. And we can take the square roots of both sides, again remembering the plus or minus. So I get plus or minus 2. And this would actually happen twice because it happened here and it would happen here. So I'm going to have 0 would be a 0 of multiplicity 1. I'm going to abbreviate multiplicity 1. X equaling 2 would be multiplicity 2, and x equaling negative 2 would also be multiplicity 2. If we were going to write this in factored form, some of the problems will ask you to write it in factored form, I would be writing this as x plus 2 squared and x minus 2 squared. And you can see that multiplicity is going to be on the power that we have those zeros. I'm going to stop the video here because with my next example it is going to take us some time to work through it, and I want to make sure that we have enough time to do so. So another really long example in the next video.